Hello everyone, I'm Alan, also known as McLaren 2009, and today I'm going to be giving you a system overview of my improved Tactical Air Navigation, or TACAN, system. As many of you are probably aware, this is my original TACAN system that uses 10 operating frequencies to transmit and receive. This is my new and improved TACAN system that uses 100 frequencies to transmit and receive. Now, the way that a TACAN system works, basically it is a redundant navigation system on board of an aircraft. Instead of, or in addition to, I should say, in addition to the GPS, kind of like the one you have in your car, It gives you your grid coordinates based on your geographic location tracked by a satellite. Well, there are other ways that you can navigate an aircraft. You can find out where you are based on those GPS grid coordinates, or you can use what are known as radio navigation beacons. These are radio stations spread out all around the world. Each one has its own unique frequency, and it's constantly transmitting. And it just transmitting its location, where it is. A plane in the air turns its radio navigation TACAN system to the frequency for that radio station, and it tells you which direction the station is and how far away it is. So the way this works in Stormworks, you have the TACAN system and all of the displays and controllers that it requires, and a GPS sensor. The GPS sensor has your X and Y grid coordinates of your aircraft. Then you have a receiving aircraft or ground radio station that is also transmitting its X and Y grid coordinates. This system works by taking your X and Y grid coordinates and subtracting them from your target X and Y grid coordinates. This forms a right triangle, and if you remember from your high school math classes, you might remember the Pythagorean Theorem, a squared plus b squared equals c squared. Well, a squared is your x difference, y squared is, or b squared is your y difference. And then c squared, that is the hypotenuse of your triangle, or the straight line as a crow flies between the two aircraft. Or two vehicles, I should say. So this system is improved over that system because this one has 100 frequencies instead of 10. So we go over here, we turn on the system. Obviously, it's set to transmit and receive on 0 by default. That's where the counter resets to. So, let's say we want to turn this one up to 1 and receive on 2. Turn on the transmitter. Okay. Now, this is set up to transmit, and it will constantly send out the X and Y coordinates on frequency 1. So, let's go back over here to my old system, turn on the system, set it to transmit on 2 and receive on 1, and before we even turn on the transmitter, as you can see, we've already received a signal from the other system. So, it is 5.65 grid coordinates west. Alright, not important. Either way, X difference refers to east and west, Y difference refers to north and south, bearing to target, that is your calculated bearing to the test vehicle. And distance to target, approximately 8. That's a little bit strange. It says it's 8.0 even, but it says 7. A little bit suspicious, but I digress. Now, as you can see on my little tool belt, I have a magnetic compass, and right now I am facing bearing 135 degrees magnetic. If I look over to my left to approximately 045 degrees magnetic, you can see that is in the same direction as the TACAN test set. So, let's turn on this transmitter on the old system, so it is now transmitting its X and Y coordinates on frequency 2 and receiving on 1. Go back to the new system, we're receiving on 2 and transmitting on 1. Just the same as the other one, you have the distance to target, bearing to target, X difference, Y difference. And as you can see, this one has a bearing of approximately 225 degrees magnetic. So we look over here to approximately 225 degrees, and lo and behold, that is the same direction to the other system. Now, you might be wondering, well, what do I need to actually install this on one of my vehicles? And that is quite simple. In order to use the TACAN system to its full functionality, you will need these 3 instrument panels, one with the frequency displays, one to select the frequencies, and this will be your control terminal. Basically, I always put transmitting frequencies in red and receiving frequencies in green, and that correlates to these dials right here. This is your transmit, this is your receive. These arrows go up and down to select your frequency from 0 to 99, and it will also reset once you get to 99. If you press up one more time, it will reset all the way back down to 0. Now, for minimal functionality of this system in your vehicle, you absolutely need a bearing to target and a distance to target. The X difference and Y difference are cool to have, but they're not required. So bear that in mind. Basically, you need these 3 blocks and these 4 blocks of 2 number displays. And that is all that you need. Now, if we go around back, you'll notice that we also need a transmit and receiving radio antenna, a microcontroller, some kind of power supply, and a GPS sensor. But anyway, that is the full system overview of my upgraded TACAN system. Thank you for your time.